Hello, Warhawks. Today we're going to be learning about Chapter 7.1, rotations and reflections in the coordinate plane. The first thing we're going to look at are reflections. A reflection is just like a mirror image over an axis, either an X or Y axis. We're first going to talk about the Y axis. So if we're reflecting something across the Y axis, it's basically like we're treating this like a mirror, and then we should see the same picture over here as we see over there. Now it's not translating, it's not sliding this over here. We actually want to see the mirror image. So we can look at this figure. We notice that the points are located at 2, 3, 5, 3, and 5, 6. So if we're rotating it, reflecting it across the y-axis, think about what the values are going to be. Over here, our values are positive x, positive y. Down here, it would be positive x, negative y. Over here, it's going to be negative x, negative y. And then over here in this quadrant, the fourth quadrant, it's going to be negative x, positive y. So I want to see this point the same distance from the y-axis over here, so right there. And I want to see this point the same distance from the y-axis except reflected over here. So it's 5 away, so we're going 1, 2, 3, 4, 5. And same thing here, this one's also 5 away, so we want to see it in the same line, 1, 2, 3, 4, 5 away. So notice what happens when we reflect across the y-axis. Our y values actually stay the same. So up here, we're going to get our new figure, which is going to be located at negative 5, positive 6. Down here we have, instead of positive 2, positive 3, we have negative 2, positive 3. And then over here we have negative 5, positive 3. So look at what happened here when we reflected this across the y-axis. Notice what changed. Our values are still the same, but what actually happened is we switched the sign of the x value. Y stays the same. Y stayed the same. So when we reflect across the y-axis, the x values change their signs, the y values stay the same. If we had been reflecting from here to there again, we would have changed from negative 5 to positive 5, from negative 5 to positive 5, and from negative 2 to positive 2. Notice how they look the same. They're mirror images of each other. If we looked at reflecting across the x-axis, which is this one, so we want a mirror image down here in this quadrant from this figure right here. So we think about what's going to happen. We're going to reflect this point, 5, 3, across the axis. So we want it to be the same distance from the x-axis. So it's 1, 2, 3. So we want 1, 2, 3 down here. Same thing here. It's 3 from the x-axis. So we want 1, 2, 3. And then this one is actually 5 or 6 from the x-axis. So we want 1, 2, 3, 4, 5, 6. So there's our new figure. Notice how it's been reflected across that axis. And then look at where our points are actually going to be located. This point turns into this, so it's still positive 5, but instead now it's going to be positive 5, negative 3. Down here, we're still going to have positive 5, but it's going to be negative 6. And then over here, we still have positive 2, but it's actually going to be negative 3. So if we look at the rule here, when we reflect across the x-axis, what actually happens is x stays the same, but y changes its sign. Okay, so we still kept the same x values, but reflecting across the x-axis, we went from positive y's to negative y's. Notice if we were going backwards, it would be the same thing. We'd just be going from negative y values to positive y values. Now we're going to look at rotations. So we're going to be rotating things around the origin, which is this central point right here, 0, 0. We're going to be rotating figures either 90 degrees or 270 degrees. Now I want you to notice that when we rotate a figure 90 degrees, it's going to change its quadrant. We have this quadrant up here, this one, and this one. So we have 4 quadrants. If we're rotating something 90 degrees, it's either going to move from this quadrant down here, or it's going to move from this quadrant over here, depending on how we're rotating it. This would be a clockwise rotation. This would be counterclockwise rotation. Now notice something here. If I were going to rotate this figure 90 degrees clockwise, it would go down here. If I were going to rotate it 90 degrees counterclockwise, it would actually end up over here. But if you think about it, rotating it 90 degrees counterclockwise is basically the same thing as rotating it 90, 180, 270 degrees clockwise. So really, we want to think about it as rotating it 90 degrees. Even if it says 270, then we really want to think about that as it's just 90 in the opposite direction. So here we see this same figure that we've been dealing with. We're going to rotate it 90 degrees clockwise, so down here. A couple things happen. We're not just going to be reflecting this. It's going to move, it's going to rotate, and it's going to change quadrants. So think about what the values down here are. Over here, we have positive x, and we have a positive y value in that first quadrant. Down here, we still have a positive x value, but now the y values are negative. So when we rotate this, we have to keep that in mind. As we rotate, we want to keep a couple of things in mind. We're going to be changing the y values. They're going to be going from positive y's to negative y's. But also something else is going to happen. We're actually going to flip-flop or switch our x and y values. So let's see what I mean by this. We have our points over here, which I'm going to write out. So here are our 3 points, 5, 6, 5, 3, and 2, 3. The first thing that we want to do when rotating 90 degrees is we want to switch those values, okay? So we're going to turn our x's and y's and flip them. So instead of 5, 6, we're going to do 6, 5. Instead of 5, 3, oops, sorry. We have 6, 5. Instead of 5, 3, we're going to have 3, 5. And instead of 2, 3, we're going to have 3, 2. Now again, remember, we're going from positive, positive, positive x, positive y, to positive x, negative y. So I need to change the signs of all these y values. And let's see where these points end up. We have a point at 6, negative 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. We have a point at 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And lastly, we have a point at 3, negative 2, 1, 2, 3, 1, 2. And then if we connect those, we can see how this image isn't a reflection, it's a rotation. And there's our new image. It's been rotated 90 degrees in this coordinate about the origin. So our rules here, we want to flip our x and y value, and we want to change to the correct sign. So let's see what this would look like if instead of rotating it 90 degrees clockwise, we rotated it 90 degrees counterclockwise, which is actually the same thing as rotating it 90, 180, and 270 degrees clockwise. But look where this is going to end up. Instead of going here, we're going to be in this quadrant. Think about the values we have. Over here we have negative x and positive y values. So we still want to do these same things. We want to flip x and y, which we have done. I'm going to scroll down here a little bit. So we had 5, 6, 5, 3, 2, 3. We turn that into 6, 5, 3, 5, and 3, 2. But this time, think about it. It's going to be in this quadrant, which means we're going to have negative x values and positive y values. So let's see where these end up. This point, negative 6, 5, is going to be at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We're going to be at negative 3, 1, 2, 3. 1, 2, 3, 4, 5. And we're going to be at negative 1, 2, 3, 1, 2. And look, there's our positive points where they're supposed to be, our negative points where they're supposed to be. Notice how it's not a reflection, it's a rotation. We've rotated this image. And here is our new image right here. So it just depends on how we want to rotate them, but they're going to be changing according to this. If you're rotating it 90 degrees, Or if it's 270, just do it backwards. Like if it was 270 degrees clockwise, it's really the same thing as 90 counterclockwise. You got to think about where this point is going to be. This shape is going to move quadrants. But you want to focus on these rules. You flip the x and y, and you change to the correct sign. The last thing we have to talk about is a 180-degree rotation. So whether we're going 180 counterclockwise or we're going 180 clockwise, they're going to end up in the same quadrant. We're going 2 quadrants. So if I'm going to the right, it's going to go 90 and then 180. If I'm going to the left counterclockwise, it's still going to be 90 and then 180. So let's look at that. So here's where our points are, 5, 6, 5, 3, 2, 3. We're going to rotate it 180 degrees. Doesn't matter whether it's clockwise or counterclockwise. We're going to be rotating it. Now the thing here that happens is this. We're basically rotating 90 degrees twice. We're going to flip the x and y, but then we're going to be flipping it again, so they actually turn back into the same thing. So our new values are going to have the same x and y values. We're going to have 5, 6. That's going to be true still. We're going to have 5, 3. Because we flipped it twice, it turns back into the same thing. Every 90-degree rotation, you're flipping. So if you go 290 degrees, it's going to be flipping twice. So these are going to stay the same. And we think about it was in this quadrant, which is positive x, positive y. But we're going 180 degrees. So we're going 1, 2 places, or we go 1, 2 places. Either way, we get to the same place, which over here we have a negative x and a negative y. So our values are going to stay the same. But over here, we're actually going to be turning these into both negatives because they're in that third quadrant, which is negative, negative. Let's see what we get here. We have negative 2, negative 1, 2, 3. So right there. We have negative 2, 3, 4, 5. 1, 2, 3. And then we had negative 5, negative 4, 5, 6. So there is our new image. It's been rotated 180 degrees. And it doesn't matter whether we're going clockwise or counterclockwise, it still should be the same thing. So, in short, if we're rotating 90 degrees, or 180 degrees, we want to keep x and y the same, but we want to change the sign correctly, depending on what quadrant we're in. If we were up here, it would be a negative x and a positive y. If we were down here, it would be a positive x and a negative y. You just really got to think about where those quadrants are. All right, we'll see you in class.